Hello everyone and welcome to this all important coverage of very important chapter in class 10th, triangles. In this particular video we are taking Pythagoras theorem, very important theorem in the chapter. We'll do its converse also. So let's begin. Now before actually taking a Pythagoras theorem, let's do a property of right triangles. Let this ABC is a right triangle with right angle at a vertex B. Now if we draw a perpendicular from this vertex containing this right angle BD to the hypotenuse AC, we now get three triangles. One, two, and one is this ABC triangle, right? So the property is that all these three triangles are similar to one another. How? Let's see. If we take this triangle ADB and ABC, this triangle and this complete triangle, okay, in these two triangles, see this angle A is common in both the triangles, okay. Also this triangle is of 90° as well as this angle is of 90° given to us. Therefore ADB and ABC both are 90° equal, okay. Now these two triangles having two corresponding angles equal means they will be similar by angle similarity. ADB, ABC both are similar by angle similarity. Let this be our equation number 1. Similarly, we can prove in this triangle BDC and ABC. This angle C is common in both the triangles and one angle is of 90°. So again these two triangles will be similar, right? Let this be equation number 2. From 1 and 2 we can write that both the triangles formed on the sides of this perpendicular drawn from the vertex containing the right angle are similar to this whole triangle ABC. Now also, since ABC is similar to BDC as well as ADB, so ADB and BDC will also be similar. Since they are similar to the same triangle, so will be similar to one another also, okay. So this is the property that when we draw a perpendicular from the in a right triangle from the vertex containing right angle, it divides the triangle in two similar triangles which are also similar to this whole triangle ABC. Let's try to put this property in words. Okay, if a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then triangles on the both sides of the perpendicular are similar to the whole triangle and to each other. Okay, we can prove this as we did in the previous slide, or we can apply this property wherever it is needed, wherever it is given that perpendicular is drawn from the vertex containing the right angle. Okay, so let's move to very important. Now see, this theorem can be stated as in a right triangle the square of the hypotenuse is equal to the sum of squares of other two sides, or simply you will ask to prove the state and prove the Pythagoras theorem. Okay, it can be asked in both the ways. So in a right triangle, let ABC is the right triangle. ABC is the right angle with right angle at B, vertex B, this way. We need to prove that AC square Square of the hypotenuse, AC square. Hypotenuse is the side opposite to the right angle, longest side in the right triangle. Hypotenuse square, that is AC square, is equal to the square of other two sides. Other two sides are AB and BC. So AC square is equal to AB square plus BC square. We need to prove this. In this, we'll do a construction. We will draw BD perpendicular to AC. Okay, now we'll prove this. So in this triangle ADB and ABC, ADB and whole ABC, they are similar by the property of the theorem we did. If you want to prove this, we can prove this by, in these two triangles, angle A is common, angle ADB is equal to ABC, both the 90-degree, and since hence this is these two triangles are similar by angle similarity criterion. Okay, if you write within the bracket that from property this is similar, okay, then also it will fine. But if you want to prove it, you can prove it this way. Okay, so similarly, now ADB is similar to ABC, so their corresponding sides will be proportional. So now see what we need to prove here. From the proportion, when we cross multiply, we'll need this square of AB and square of BC and square of AC. Since AC is divided into two parts, AD and DC, so the combination of AD and DC will be on this side, and we'll get need to get AB square BC square. From there we write the proportion in such a way, ratio in such a way, that while cross multiplying we'll get either of these. Okay, so here AD AB, AD AB is equal to AB AC. From here we can get, or we will get, AD into AC is equal to AB square. Let this be equation number 1. Clear this thing? When we transpose this AC to this side, it will be multiplied in AD, and we transpose this AB to this side, AB into AB, AB square, right? Similarly, this BDC triangle is similar to ABC from property or from theorem, or if you don't want to write this, you can prove this way. In these two triangles, this angle is common. Okay, one angle is of 90 degree in both the triangles, so they will be similar by angle similarity criterion. From here we'll write the ratio of two sides. Once again, AB square is in equation number 1. We need BC square now on this side. So DC upon BC is equal to BC upon AC. This will give us DC into AC is equal to BC square. Let this be our equation number 2. Now add this equation number 1 and 2. What will get? AC in AD into AC plus DC into AC is equal to AB square plus BC square. Okay. Further on simplifying, AC is common, so in the bracket we are left with AD plus DC is equal to AB square plus BC square. Now see, AD plus DC is AC. Okay, so this is replaced by AC, then AC multiplied by AC gives you AC square. AC square is equal to AB square plus BC square. Hence proved. This was what we were proving here. AC square is equal to AB square plus BC square. Okay, so this is our Pythagoras theorem. In a right triangle, the square of the hypotenuse is equal to the square of other two sides. Okay, now see, other two sides are named as base and perpendicular. So this is the notion for this Pythagoras. H square is equal to B square plus P square. Now see, the application of Pythagoras theorem, we can derive equation for or formula for this b square and p square as well from this equation by transposing, simple transposing. If we want to write b square comes out to be h square minus p square. Similarly, p square comes out to be h square minus b square. And further, if we need to find the value of h, b, and p, it will be h will be given under root the sum of b square plus p square. Okay. Similarly, b will be given as the under root of difference between h square and p square, and this p is given by under root difference of h square and b square. So all these equations will be applied in different ways in different questions where we need to find h, b, or p accordingly. And this Pythagoras theorem or this property of this right triangle will be used in other chapters also. So be very careful and be very in understanding this theorem. This is very actually very simple also. Okay, so let's move to the converse of this theorem. Converse means in a triangle, if square of one side is equal to the sum of squares of other two sides, then the angle opposite to first side is a right angle. This is the converse of PGT, Pythagoras theorem. Pythagoras theorem states that in a right triangle, the square of hypotenuse is equal to the square of sum of the square of other two sides. Its converse is if the square of one side is equal to the sum of square of the other two sides in a triangle, then the angle opposite to the first side is a right angle. Okay, so let's ABC is a triangle in which AC square is equal to AB square plus BC square. We need to prove angle B is equal to 90 degree. For this, we'll construct a triangle PQR, right triangle PQR, such that like it's PQ is equal to AB and QR is equal to BC. This way, PQ is equal to AB and this QR is equal to BC. We construct this triangle by ourselves. Now, proof these two sides are by construction equal. AB is equal to PQ, BC is equal to QR. So, in triangle PQR, by Pythagoras theorem, we can write that this PR square is equal to PQ square plus PR square. By Pythagoras theorem, in right triangle, square of hypotenuse is equal to the square of sum of squares of other two sides, right? Now replace this PQ by AB and this QR by BC. What we get? We get PR square is equal to AB square plus BC square. We can replace this because PQ is equal to AB and QR is equal to BC by construction, right? Let this be equation number 1. But we are given in beginning that AB square plus BC square is equal to AC square. Let this be our equation number 2. So now see from these two equations 1 and 2, sum of AB square and BC square is equal to PR square as well as AC square. AB square plus BC square is equal to PR square is equal to AC square, which implies this PR square is equal to AC square. Okay, from 1 and 2 we can write that PR square is equal to AC square or PR is equal to AC. This PR is equal to AC. Let this be equation number 3. Now in these two triangles ABC and the triangle be constructed PQR, AB is equal to PQ and BC is equal to QR by construction. Also this AC is equal to PR from equation number 3. We just proved this. So from these we can write that ABC and PQR are congruent triangles by side congruency criteria. In two triangles, when all the corresponding sides are equal, then the triangles will be congruent. Okay, so if they are congruent by CPCT, we can write that this angle B is equal to angle Q. Okay, and angle Q is constructed 90 degrees, which implies angle B is equal to 90 degree as well. Hence proved the converse of a Pythagoras theorem. Okay, we proved this by constructing a triangle, right triangle, and applying PGT on that, then proving the two triangles congruent this way. Clear? So these are two theorems, rather three theorems: PGT, converse of PGT, and it can be asked in many ways. Means directly you are asked to prove the converse of PGT, or you are given the statement like this: in a triangle, if the square of one side is equal to the sum of the squares of other two sides, then the angle opposite the first side is a right angle. Similarly, PGT can be asked in many ways, or simply to state and prove PGT, Pythagoras theorem, or in a right triangle, the square of hypotenuse, prove that the square of hypotenuse is equal to the sum of the square of other two sides, right? So go through it once again and make sure that everything is clear to you. Okay, now see, now see, self-belief is the way to build your self-confidence. Okay, so in next video we'll take exercise 6.5 based on this Pythagoras theorem. Till then, keep working hard, keep drilling, and keep practicing. Keep your mind full of positive thoughts. And thanks for watching.